Today we'll be doing the integral from 0 to infinity of the square root of x times the squared natural log of x divided by 1 plus x squared dx. And to start off, we will construct a function. We will call this function f of s, and it will be equal to the integral from 0 to infinity x to the s minus 1 over 1 plus x squared dx. And this is the Mellin transform of 1 over 1 plus x squared, which is equal to pi over 2 cosecant of pi s over 2. And then we will differentiate with respect to s. So f prime of s will equal the integral from 0 to infinity x to the s minus 1 ln x divided by 1 plus x squared dx is equal to pi over 2 times the derivative of the cosecant of pi s by 2. So f prime of s is the integral from 0 to infinity x to the s minus 1 ln x over 1 plus x squared dx is equal to pi over 2, and this derivative will be negative cosecant of pi s by 2 cotangent of pi s by 2 times the chain rule, so you have an extra pi over 2, so you have a negative pi squared and a 2 squared. So this will be negative pi squared over 4 cosecant of pi s over 2 and then a cotangent of pi s over 2. Now I'm going to differentiate with respect to s again. So we have f double prime of s is the integral from 0 to infinity x to the s minus 1 squared natural log over 1 plus x squared dx, which will be negative pi squared over 4, the derivative with respect to s of the cosecant of pi s over 2 and the cotangent of pi s over 2. And we're interested in the case when s equals 3/2. We now have that our f double prime of s is equal to minus pi squared over 4 times the derivative of cosecant of pi s over 2 times the cotangent of pi s over 2. And now we have to differentiate this, and I'll label this f and this g. So this is equal to negative pi squared over 4, and using the product rule we have g f prime plus f g prime. So we have a minus pi squared over 4. G will be cotangent of pi s over 2. F prime will be negative cosecant of pi s over 2, cotangent of pi s over 2, times the chain rule, which would be an extra pi over 2, and the plus f, which is cosecant of pi s over 2, times g prime will be a negative cosecant squared of pi s over 2 times an extra pi over 2. So this is equal to minus pi squared over 4. We're going to have a negative pi over 2, a cotangent squared of pi s over 2, an extra cosecant of pi s over 2, and we'll have a plus negative pi over 2, so there's that, and we have a cosecant cubed of pi s over 2. And we're interested in the case when s is equal to 3/2. So if we plug in s equals 3/2, we have the f double prime of 3/2 is negative pi squared over 4, negative pi over 2, cotangent squared of 3 pi over 4, times the cosecant of 3 pi over 4, and we'll have a minus pi over 2 cosecant cubed of 3 pi over 4. And we have to remind ourselves that the cosecant of 3 pi over 4 is 2 over root 2, and the cotangent of 3 pi over 4 is negative 1. So f double prime of 3/2 is negative pi squared over 4, negative pi over 2, Cotangent of 3 pi over 4 is negative 1 squared. Cosecant of 3 pi over 4 is 2 over root 2 minus pi over 2. Cosecant of 3 pi over 4 is 2 over root 2, but it's now cubed. So negative 1 squared is 1. These two divide to 1 is equal to minus pi squared over 4. Negative pi over root 2 minus pi over 2. 2 cubed is 8. And the square root of 2 cubed is 2 over root 2. So we're left with negative pi squared over 4 minus pi over root 2 minus 8 pi over 4 times root 2. And from here we can get a common denominator. This is equal to minus pi squared over 4 negative 4 pi root 2 minus 8 pi root 2 over 4 times 4. Well, no, it would be 4 times 2 because square root of 2 times the square root of 2. So it would be minus pi squared over 4 negative 12 pi root 2 over 8. And we could write this as minus pi squared over 4. 12 is the same thing as negative 3 times 4 pi root 2, and 8 is 2 times 4. So the 4's cancel, and we're left with minus pi squared over 4 negative 3 pi root 2 over 2, which simplifies to 3. And negatives cancel, we're left with 3 pi cubed root 2. 4 times 2 is 8, which is the value of our desired integral, the square root of x squared logarithm over 1 plus x squared dx. Thank you very much for watching.